Ever get confused when graphing inequalities? You know, when you have something like y is greater than x plus 2 and you're not sure which side to shade? Today, I'm going to show you a super intuitive method that eliminates all that confusion. No more plugging in test points, you'll know instantly which region is the solution.
Here's the situation. You have an inequality like y is greater than or equal to x plus 2, or maybe 2y is less than negative 2x plus 1. You draw the line, but then what? Which side do you shade? A lot of students pick a test point, plug it in, and see if it works, but there's a much faster way.
Let's think about how the coordinate plane works. As you move up, y values get bigger. As you move down, y values get smaller. Similarly, as you move right, x values increase, and as you move left, x values decrease. This is the key to our intuitive method. Here's the golden rule. If you have y greater than something, you need y to be bigger, which means you go up, so you shade above the line. If you have y less than something, y needs to be smaller, which means you go down, shade below the line. The same logic applies to x. X greater than means go right. X less than means go left. It's that simple. Let's apply this to an example. We have y is greater than x plus 2. First, we draw the boundary line y equals x plus 2. Since there's no equal sign in the inequality, we use a dashed line to show that points on the line itself aren't included. Now, since we have y greater than, we need to go upward. So we shade everything above the line. Done. Here's what it looks like. We have our dashed line with slope 1 and y-intercept 2. The entire region above this line is shaded. That's our solution. Any point in this blue region satisfies the inequality y is greater than x plus 2. Let's try a trickier one. We have 2y is less than or equal to negative 2x plus 4. First, let's solve for y by dividing everything by 2. We get y is less than or equal to negative x plus 2. Now we draw the line y equals negative x plus 2. Since we have less than or equal to, we use a solid line because the boundary is included. Since y is less than or equal to, we go downward and shade below the line. Here's our graph. Notice the line is solid because of the equal sign in our inequality. We've shaded everything below the line. The solution region includes the line itself and everything beneath it. Let's look at an x inequality. We have x is less than 3. This gives us a vertical line at x equals 3, and since there's no equal sign, we use a dashed line. Now, x less than 3 means x needs to be smaller, which means we go left. So we shade everything to the left of the line. And here it is, the vertical dashed line at x equals 3 with everything to its left shaded. This represents all points where the x-coordinate is less than 3, regardless of the y value. One more important detail, how do you know whether to draw a solid or dashed line? It's simple. If the inequality includes an equal sign, greater than or equal to, or less than or equal to, use a solid line because points on the boundary are part of the solution. If there's no equal sign, just greater than or less than, use a dashed line to show the boundary itself is not included. And that's it. You now have a completely intuitive method for graphing inequalities. Y greater than? Go up. Y less than? Go down. X greater than? Go right. X less than? Go left. And remember, equal sign means solid line. No equal sign means dashed. No more test points, no more confusion. Just follow the direction the variable needs to go, and you'll nail it every time.